Blue carbon refers to the carbon stored in coastal and marine ecosystems, including mangroves, seagrasses, and salt marshes. These ecosystems are vital in mitigating climate change by capturing and storing atmospheric carbon dioxide more efficiently than other terrestrial ecosystems. Mangroves, in particular, play a significant role due to their ability to store large amounts of carbon in their biomass and waterlogged soils, where it remains trapped for centuries. This makes them crucial natural carbon sinks, helping reduce greenhouse gas concentrations and protecting coastal areas from climate impacts. Recognizing the importance of mangroves in carbon sequestration is essential for developing effective conservation strategies to combat global warming. Mangroves are vital coastal ecosystems known for their ability to capture and store carbon, known as blue carbon, in both their biomass and soils. This makes them essential in combating climate change. However, human activities like deforestation and pollution threaten their abilities to act as carbon sinks, releasing stored carbon back into the atmosphere. Conservation efforts now focus on protecting and restoring mangroves with economic incentives like carbon credits, encouraging sustainable management and aligning environmental goals with financial benefits. Understanding how mangroves sequester carbon is the key to enhancing their role in climate mitigation.
For this blue carbon and the role of mangrove in carbon sequestration paper, there are a total of 5 objectives, which are: the first one, to investigate the mechanism and significance of carbon sequestration in mangrove ecosystem. Second one, to compare the factors that contribute to blue carbon sequestration health. Thirdly, to analyze and evaluate human impact and threat on the health of the mangrove ecosystem. Fourth, to explore the conservation strategy for rehabilitating mangrove ecosystem. Last but not least, to evaluate the economic incentive for mangrove conservation. Based on the literature review, according to Maiti and Chowdhury in 2013, carbon emissions are the chief contributor to climate change and global warming. Thus, according to Ahmad and Bortoli in 2022, mangrove forests, seagrass manure, and tidal marshes that make up this ecosystem as low carbon ecosystem play a crucial role in regulating our climate. However, according to Marchio Jr. in 2016, mangrove worldwide face destruction due to human activity, which lower the rate of carbon sequestration based on its location. Distributions of mangrove may be included in the effort to establish a worldwide market opportunity for reduced emissions from deforestation and degradation based on Gordon and predation study in year of 2011 and 2000. Next, there are a few research gaps for this paper. As you can see here, I will only highlight 3 main research gaps from this paper. The first one is some part of the BC research remain debatable today as it had different view on the importance of carbonate formation as a component of BC and the sweet contribution to BC. Many estimations fail to take additional process such as denitrification, sulfur, and inorganic carbon cycle into consideration, which may greatly outweigh sequestration as source of CO2 emission to the environment. Lastly, based on the research done in 2023, the technique utilized to evaluate cord stock are different throughout the country, and the choice approach is mostly determined by the option of the research itself and the cost associated with the element analysis price.
I'm going to explain about methodology from this research. It has 3 methods, which is above ground biomass. From this method, we need to take a sample collection such as stem, branches, and leaf, and we need the sample to dry at 70 degrees Celsius to get our sample analysis. So for the carbon analysis, we need to use CHN analyzer, which is carbon, hydrogen, and nitrogen analyzer to get the carbon analysis. For the second method, we use below ground biomass. We take soil sampling and use sequential soil coring by we need to separate the root and the soil as we wash and sort the root. To measure the root, we need to dry and wet the root to estimate the carbon content. Method 3, we use soil organic carbon. Soil organic carbon, we use the soil collection from previous method as our carbon content analysis. So it have three methods to analysis the carbon content. First, we use wet digestion, which is a method that used by Walke and Black in 1934. And then we use dry combustion as to loss on ignition as carbon content analysis.
So next, I'll be explaining about the result part based on the research objective. So the first objective of this assignment is to investigate the mechanism and significance of carbon sequestrations in the mangrove ecosystem. So for mechanism, the process used is the biogeochemical processes, which is essential in maintaining the balance of the element in our ecosystem. So the biogeochemical processes, such as phosphorus cycle, nitrogen cycle, and carbon cycle, are very important to maintaining the balance, to maintaining the number of elements that exist in our ecosystem. So the significance is first to reduce the risk of atmospheric carbon dioxide levels, and second because mangrove contains significant amount of hydrogen sulfide, which act as reducing agent. So here are some explanation regarding this, where under light circumstances, there are huge number of anaerobic bacteria which will utilize the hydrogen sulfide which can help to reduce the amount of carbon dioxide by transforming the carbon dioxide into organic matter. So by using this method, it can help in reducing the number of carbon dioxide that exists in our atmosphere. in our ecosystem. This table shows how much carbon dioxide are sequestered in the mangrove, salt marshes, and also the seagrasses. So for the first table is between the mangrove and salt marshes, and the second table is for mangrove and seagrass. So for the first table, the carbon is sequestered in mangrove is about 38.3 kg, C.A with the power of -1, and for salt marshes, 12.6 kg, C.A with the power of -1. So as we can see here, that mangrove have higher number of carbon sequestered compared to salt marshes. So in mangrove and seagrass area, for in this table, there are two types, which the first one is the soil mass carbon, and the second one is carbon accumulations by roots. So for the soil mass carbon is around 1.74 to 2.5 mg carbon per hectare per year, and for the second one is the carbon accumulation by roots, which is 5.06 to 6.63 mg carbon per hectare per year. So when compared it to seagrass, it only has 74 to 161 kilogram carbon per hectare per year. So as we can see here, that mangrove also has number of high carbon sequestered compared to seagrass. So what I can conclude here is mangrove are regarded as the most effective coastal blue carbon ecosystem for carbon sequestration. So next I will be explaining the second objective of this assignment, which is to evaluate the factors that contribute to the blue carbon sequestration health. So as we know that the process may be interfered with and impacted by the variety of interrelated biological, biogeochemical processes, and also the physical as well as human activities, that whether it is directly impacted or not directly impacted to the environment. So here are some factors that contribute to the blue carbon sequestration health, which is the first one is sea level rise, temperature, precipitation, atmospheric carbon dioxide, extreme weather event, community life, genera, and also age. For sea level rise, the landward expansion brought out by sea level rise result in an increase in habitat and carbon sequestration. And for the second one is the temperature, where this temperature, when global warming risks occur, it will give beneficial feedback to the mangrove, which can enhance the plant growth and also the expansion of the mangrove to the higher latitudes. So this third one is the precipitation, where the rainfall, higher rainfall will lead to higher productions and more carbon are being sequestrated. So for atmospheric carbon dioxide, it is where increase in carbon dioxide may aid in the storage of carbon in the sediments and the ability of blue carbon ecosystem to adapt to the sea level rise. For extreme weather events such as typhoon, forest fire, and even floods, this can cause destroy and harm the mangrove area. This is because the mangrove are not in their positions. This will lead to carbon are not being sequestered and causing higher number of carbon dioxide are in the atmosphere. For the community type, so the river mangrove having the highest sequestration level, where it should be prioritized for density enhancement, protection, preservation, and conservation in order to improve the sequestration levels. For genera and also age, it is very important to make sure that the carbon are being sequestered so that in the atmosphere the carbon dioxide release are less. So now I will explain the research objective of explore the conservation strategies for rehabilitation mangrove ecosystem. So in this research paper, there are some conservation strategies are being explained about, which is the international collaborations between the UNFCCC, which is the UN Framework Convention on Climate Change, and CBD is Convention on Biological Diversity. So the next one is establish worldwide market opportunity for REDD+2. REDD+2 is a reduced emission from deforestation and degradation. Next is new financing mechanism, and lastly is incorporating with the expertise of local communities and indigenous people into planning and management blue carbon strategies. So for the objective in analyze and development impacts and threats on the health of mangrove ecosystem and evaluate the economic incentive for mangrove conservation will be further discussed in the discussion part.
Carbon sequestration refers to the process of capturing and storing carbon dioxide or other carbon compounds. Mangroves absorb carbon dioxide from the atmosphere during photosynthesis and store it in their tissue. Mangroves are proven to be the most effective coastal ecosystem for carbon sequestration compared to seagrass ecosystem and salt marshes. The amount of carbon stored in mangrove is determined by physiochemical processes such as tidal pumping, pore water exchange, and others. Mangrove also acts as a buffer in which they slow down water flow and reduces wave energy. Other than that, they also promote because estimation of mangrove biomass can help us to determine the amount of carbon dioxide the forest can trap from the atmosphere. The accurate estimation of mangrove biomass is crucial for timber extraction, tracking changes in forest carbon stock, and global carbon cycle. Activities such as agriculture, urbanization, aquaculture, mining, and excessive timber harvesting can impact the overall health of the mangrove ecosystem. Aside from that, cutting down of mangrove for fuel, water pollution, development, industrialization, and discharge of herbicide residual also poses threats to the mangrove ecosystem. Mangroves can provide local fisheries with economic benefits, with pinnate shrimps being the most economically viable fishery. Next, mangrove can also add value through tourism, education, and cultural practices. Other than that, mangroves ecosystems are used to provide income for local communities using voluntary carbon markets by selling carbon credits equivalent to carbon sequestration.
To conclude this research, mangrove ecosystems are essential carbon sinks because they effectively store significant amount of carbon in biomass above ground, below ground root, and soil organic matter. This carbon ecosystem also providing habitat and space for coastal and marine wildlife to thrive, and as well as become a natural defense for coastline from erosion. The study emphasized how crucial it is to estimate carbon stock accurately utilizing cutting-edge techniques like CHN analyzer, carbon hydrogen analyzer, remote sensing, and soil analysis. Mangrove resilience can be increased, and their ongoing contribution to global carbon sequestration can be guaranteed through conservation measures such as creation, restoration, and preservation. Yet, the policy establishment and the implement of strategy as well as demonstration of blue carbon benefit are still in their early development. Moreover, exploring every possible option for climate change adaptation and mitigation in mangrove ecosystem require more biological knowledge.